Welcome to The Explainer. Hey, if you're laser-focused on writing cleaner, more efficient, and, let's be honest, just more elegant Python code, well, you are exactly in the right place. Today, we're targeting a major milestone in any programmer's journey. We're moving way beyond the basics and mastering some seriously advanced data structures. Specifically, we're going to unpack two incredibly powerful tools hidden right inside Python's collections module, ChainMap and Counter. By the end of our time together, you'll see exactly how these two game changers can simplify your complex code and save you a massive amount of manual logic.
Okay, let's dive into this by confronting a scenario literally every coder has faced. Think about the last time you needed to merge multiple sets of data. Like configuration settings from different files? Or what about the last time you had to count the frequency of items in some giant, messy list? If you're relying on standard Python dictionaries, you usually end up writing manual for loops. You create an empty dictionary, you loop through your data, and then you write these clumsy if-else blocks just to avoid key errors or deal with all that .get clutter. I mean, it works, sure, but it's messy, it's super prone to bugs, and frankly, it just clutters up an otherwise beautiful code base. But what if there was a built-in way to bypass all that manual heavy lifting?
Which brings us to our first advanced tool, the dictionary combiner. Enter ChainMap. So what is it? By definition, ChainMap is a Python tool used to combine multiple dictionaries into one single unified view. Now, the absolutely crucial word here is view. It doesn't force you to copy all the data from 3 different dictionaries into a brand new 4th dictionary, because honestly, that just wastes memory and processing time. Instead, it logically links them together. So as far as your program is concerned, it's looking at one massive dictionary, but under the hood, your original dictionaries, they remain completely untouched and distinct.
To really grasp this, let's ground it in a real-world scenario from our source material. Imagine you have a software application that relies on user settings. You've got one dictionary storing a user's home settings, stuff like their preferred display theme or their local time zone. But you also have another dictionary storing their office settings, like enterprise server configurations or strict work email protocols. Your goal is to run the application, which means you need to access both of these settings together, seamlessly, without constantly checking which dictionary holds which setting.
And this brilliantly illustrates how ChainMap solves that exact problem. When you wrap those two separate dictionaries in a ChainMap, the output gives you a combined view. So when your code needs to access a specific value, let's say the display theme, it simply asks the ChainMap. The ChainMap then searches through those linked dictionaries, finds the value, and boom, returns the output to you instantly. You interact with it exactly as if it were just one standard dictionary. Absolutely no manual merging loops required.
But wait a second, what happens if both your home settings dictionary and your office settings dictionary contain the exact same key? For example, what if they both have a key called volume_level? So the crucial point is this rule right here. If the same key exists, the first dictionary value is used. This is a massive feature because it introduces the concept of priority.
When you build your chain map, the order in which you list your dictionaries really matters. When a duplicate key collision happens, ChainMap just stops searching the second it finds the first match. If Office settings is placed first in the ChainMap, its volume level wins, period. This is absolutely perfect for managing default settings versus user-overwritten settings. You just put the user-specific dictionary first and the system defaults dictionary second. It's an incredibly elegant way to handle fallback data.
Let's move to our second heroic coding solution and see how this builds into our next tool, the frequency analyzer. Meet Counter. As the definition clearly lays out, Counter is a Python tool that counts the frequency of elements. It's basically a specialized dictionary designed for one specific job, keeping a tally. Instead of you writing a loop to say, if this item is not in the dictionary, set it to 1, else add 1, Counter does all of this initialization and incrementing for you automatically.
And the practical applications for this, they are practically endless. Look at these real-life examples from our sources. You can use Counter for counting votes in an election app. You can use it to count words in a document to figure out keyword density. You could count students in different class sections or aggregate product sales to see exactly which item is flying off the shelves. Anytime you have a raw list of data and you need to know how many of each, Counter is absolutely your best friend.
Now, what's really interesting about this is how instantly Counter translates raw data into meaningful visual analytics. Let's say you feed Counter a raw list of numbers. Instantly, it automatically groups and tallies them. We see right away that the number 3 appeared 3 times and 2 appeared 2 times. What would normally take several lines of iterating is reduced to a single, highly readable line of code.
transforming a completely chaotic list into a clean, quantified dataset.
And it doesn't just work on lists of numbers either. Because Counter works on any iterable data, you can pass it a string of text. If you ask it to count letters, it will instantly break down the word and return a dictionary-like object showing exactly how many times each character appeared. It is incredibly fast and deeply integrated into Python's underlying C code, which makes it way more efficient than any manual loop we could ever write in standard Python.
But perhaps the greatest superpower of Counter is finding the extremes. Once your data is counted, you almost always want to know the winner, right? Who got the most votes? Which product had the most sales? The Counter tool easily identifies the most common elements. You don't have to write any custom sorting algorithms to figure out which key has the highest integer value. Counter handles all that sorting logic internally and gives you exactly what you need, right out of the box.
So, let's go head-to-head and look at the key differences between these two.
Looking at these tools side by side makes the core differences crystal clear. Let's look at their actions first. ChainMap's entire purpose is to combine dictionaries into a single view. Counter's action is totally different. It is an analyzer that counts frequency. Now look at the data comparison. This one is vital. ChainMap specifically expects to work with dictionaries. You feed it dictionaries and it links them. Counter, on the other hand, works with any iterable data. Lists, strings, tuples, you name it. You feed it a sequence of items and it returns a dictionary-like tally. Two different inputs, two entirely different problem sets, solved beautifully.
Let's bring it all together for our final summary.
To recap the essential takeaways from our sources. First, when you have multiple dictionaries and you need to access their data as if they were just one single dictionary without copying data and while perfectly managing priority, ChainMap is your go-to tool. Second, when you need to tally up occurrences of items, eliminate that messy manual for loop and initialize Counter. And finally, remember that Counter is exceptionally useful across a huge range of fields, from basic word counts to complex voting and business analytics. These tools exist to make your code cleaner, faster, and just much more Pythonic.
We started today by agitating the headache of messy, manual loops and convoluted data merging. Now you have the specialized tools to handle complex settings management and instant frequency analytics with just a few keystrokes. The heavy lifting has been totally taken care of for you by Python's advanced collections. So the only question left is, with these powerful new tools in your arsenal, what will you build next? Thanks for joining me for this explainer, and happy coding.